Okay, so welcome back to this video. So this is the second basic formula or stoichiometry of composition, right? This is the second basic formula, right? Okay, so this second basic formula now, it has two aspects. It has two aspects. Remember, this is our second basic formula, right? Whereby we have N is equal to C molar times V. And I see that, okay, in any situation whereby in the question you are seeing V, your volume is given in the form of, it was given in the form of dm cube, right? It was given in the form of dm cube, or it was given in the form of liter. If it's given in this form, just know you are going to make use of this formula. And in that particular question, what you are seeing is what? You are seeing molar, like molar concentration. For example, assuming you are given something like this, determine the number of moles. Number of moles is always denoted with small letter m. Number of moles is different from number of molecules. Determine the number of moles present in 250. The number of moles present in 2 liter. 1/5 molar HCl. Okay, we are given something like this. Determine the number of moles present in 2 liter 1/5 molar HCl. Now, if you look at this, you discover that, okay, the first thing I'm going to do is what? To list out the parameters involved. Solution. Listing out the parameters involved, that is the first thing I always tell my students. Listing out the parameters involved, okay? The volume here is what? 2 liters. Then they gave us molar concentration. How do you know? That in molar, remember, any concentration that is in form of molar is a molar concentration, or we call it molarity. Okay, so it is equal to 1/5 molar. Or you can say this is equivalent to 1/5 mole per dm cube. Okay, but you cannot solve something this way. You have to convert it to decimal so that it will give you 0.2 mole per dm cube. Do you get? Okay, then they are asking you to find the number of moles. Number of moles here is unknown. That is question mark, right? The number of moles here is unknown. So for us to solve this, what are we going to do? We are going to say, okay, what is the applicable formula we are going to use here? The applicable formula. You see that the parameters we listed out will help us to know what we are given and what we are expected to find. We are given V is equal to what? Is equal to 2 liters. Then C molar, that is molar concentration, is equal to what? Is equal to 1/5 molar, right? And that 1/5 molar is equivalent to saying 0.2 molar, or you can say 0.2 mole per liter or mole per dm cube. Okay? Then number of moles is what you are looking for. The applicable formula should be what? The applicable formula should be that N is equal to C molar times V. Okay, hence what you are going to have is number of moles is equal to what? Is equal to 0.2 times what? Times 2. 0.2 times 2 at the end of the day will give you 0.4 moles as the answer. You get now? Okay, so you see that you easily got this because we are able to list out the parameters involved, and we are able to know that, okay, we are going to follow the basic formula 2. And why were we able to follow it? I told you that whenever you are given volume and it's in liter, either liter or dn cube, either liter or dn cube, and you are seeing molar concentration there available, okay, then the volume that are giving you is in dn cube or liter, you will use this particular formula. But in any situation whereby this is not what you are seeing, in any situation whereby, okay, you are seeing molar concentration, but the volume you are seeing is either in cm cube or in mil, what formula are you going to use? You are going to use the formula that says N is equal to C molar times V divided by the conversion factor, which is 1000. Why? The reason is this. You know, C molar concentration is always in what? Mole per dm cube, right? Mole per dm cube. Then volume, if volume happens to be in cm cube or mil, in cm cube or mil, what will happen is, once you divide something that is in cm cube or something, a volume that is in mil, once you divide it by 1000, you've automatically converted the thing to what? To dm cube or to liter. Do you get? And the reason behind this is what? The reason behind this is because of the fact that 1 dm cube is equivalent to what? To 1000 cm cube. The reason behind it is that 1 dm cube is equivalent to what? 1000 cm cube. Do you understand it now? Okay, so when you want to convert something that is in dm cube to cm cube, you multiply that thing by what? 1000. When you want to convert something that is in dm cube to cm cube, you multiply that thing by what? 1000. But when you want to convert something that is a kind of, that thing is in cm cube, that thing is already in cm cube, you want to convert it to dm cube, you do the backward process of what you did here. What are you going to do? Here you multiply by 1000, that is by 10 raised to power 3. Here you are going to multiply by 10 raised to power minus 3. And 10 raised to power minus 3 is the same thing as saying you divide that thing by what? By 1000. You get now? Okay, so if you want to convert anything in cm cube to dm cube, you divide by 1000. That is why that conversion factor of 1000 entered there. So whenever you have a question and you discover that the volume is appearing in cm cube or is appearing in mil, what are you going to do? Just know you are going to bring in that conversion factor in order to solve that thing very, very well. So that means that the basic formula you are going to use is N is equal to C molar times V divided by what? 1000. You see that if this thing happens to be in cm cube, or if it happens to be what? A mil, you've brought in this. Are you getting me now? You've brought in this. Let's expect the next video.